I have actually probably beaten into your thick skulls that you should actually do your homework, so you don't even need it no more. We'll see.
The only one you really have to beat it into is me. And you've had to do that every single year we've had things together. Well, your mother seems to.
No, once I started doing the Google Classroom thing, you started doing it.
His mom realized that he wasn't doing it.
Well, yeah, that's the thing.
I think there's like one person who didn't do homework more than I ever did. Speaking of something, that Jeremiah kid from Algebra 1. He just did it because of. No, he didn't do it. He didn't do it.
All right. What lesson are we on? What are we doing today?
2, 3, and 4.
All right. That sounds like so much fun. Yeah. What numbers did we do on 2, 3?
12 through 44.
Yeah. Okay. Number 12 is 2x cubed minus x squared minus 41x minus 20. 14 is 36x to the fourth minus 36x cubed plus 24x squared plus 9x plus 6 plus 12 over 3x plus 12. 16 is 2x squared minus 8x minus 9 plus 5x plus 24 over 2x squared plus x minus 12. Oh, well, that'll work. It's not really what I meant to call it, but that's fine. 18 is 4x squared minus x minus 3 minus x plus 10 over 3x cubed plus 2x squared minus x plus 6. 20 is 2x cubed minus 2x squared plus 4x minus 4 plus 8 over x plus 3. 22 is x to the fourth minus 2x cubed plus x squared plus 4x plus 1 plus 4 over x plus 2. 24 is 12x cubed minus 6x squared plus 6x minus 12. 26 is 12x to the fourth plus 4x cubed plus 6x squared minus 4x plus 15 fourths plus 9 over 4 times the quantity 4x plus 1. We went through 44?
44, yes.
Yeah, okay, great. 28 is 8x to the fifth minus 12x cubed plus 6x squared is minus 15. 30 is somewhere, where is it? 540 meters. 32 is 11,165. 34 is 247,388. 36 is negative 686. 38 is yes and no. And f of x equals x plus 2 times the quantity x minus, no, x cubed minus 4x squared minus x plus 3. 40 is no and also no. 42 is yes and no, and it's f of x equals quantity 4x minus 1 times quantity x cubed minus 9x minus 30. And 44 is no and also no. What questions do we have on that lesson?
14. 12.
14.
12.
Yeah, I messed up on both of those, but it's because I did the wrong.
I got a surprising amount of those right.
Yeah, I just messed up consistently on the roll.
I don't need to do 12 and 14. I just need one of them. I messed up a couple.
Well, I'm doing 14, so. 3x plus 2 into.
It's the easiest thing to mess up.
Yes, and
108 x to the fifth, excuse me, minus 36 x to the fourth plus 75x squared plus 36x plus 24. Okay, what should we do?
Times to factors into 108.
We gotta add 0x cubed.
Yeah.
Oh, yeah.
Add 0x cubed. And then what?
And then we find how many times 3x divide 108 by 1.
Yeah, so what 108 x to the fifth divided by 3x is how many?
27. That's 24. Wait, 36x to the fourth. That's
Yeah.
the right number.
36. What am I doing? Yeah, 36 x to the fourth. Now what?
Multiplication and then subtraction.
Yeah. So 108 x to the fifth.
Why'd you write 180?
I don't know. Plus 72 x to the fourth. Then we subtract. Negative 108 x to the fourth. That's nice, because we already figured out that 108 divided by 3 is 36. So negative 36 x cubed. Distribute back out. Negative 108 x to the fourth minus 72x cubed. Subtract. 72x cubed. Do we actually have a question on this problem, or are y'all just trying? Are y'all just using me to find your tiny error?
We're just using you.
I'm trying to make sure I got the whole process.
Okay,
down.
great. 3x goes into negative 36x cubed how many times?
Say that one more time.
12.
Negative 12.
Yeah, negative 12.
I don't know. 33, you're right, but I'm not really even asking the right question. 3x goes into 72x cubed how many times?
That would be 24. Negative, or no, just 24. I just did 36 times 2.
24x
Squared. And then distribute back out. 72x cubed. Better be, right? Or we did something wrong. And then plus 48. X squared. Don't forget to bring down the plus 75x squared. Then we subtract.
So where did I mess up?
75x squared minus 48x. 27x squared. 3x goes into that how many times? 9x times. 27x squared. 9x times 2 is plus 18x. Don't forget to bring down the plus 36x. Then we subtract. It is 18x. 3x goes in that 6 times. 6 times that is 18x. 6 times that is 12. Don't forget to bring the plus 24 down. We subtract. And we get 12. And then we write 12 over that at the end, and then we are done.
I messed up by leaving off the entire last step.
Good job.
I messed up at the start. But now I remember.
You do know I'm recording these, like, for y'all, right? Like, you don't have to, like, just, I mean, you can use the book, too. That's a great resource. But, like, the reason that that is going right now is for you people. So if that happens again, don't forget you can always go back. You just have to go to the live tab on Ember Learning Labs.
What do you mean, you people?
Y'all, the three of you. You can't do a Robert Downey Jr. impersonation. It's not even Robert Downey Jr. It's the other guy. What's his face? That says the line. I can't remember that actor's name, but whatever. Anyway. Oh no, it is Robert Downey Jr. that says that line. It's from a movie that is not really inappropriate, and it's not supposed to be. It's called Tropic Thunder.
Oh, I've heard of that. I want to watch it.
In that movie, Robert Downey Jr. plays a a dude disguised as another dude playing another dude. He goes permanent blackface in the movie.
I just watched a great movie last night.
Did you? What was this great movie?
Mrs. Doubtfire.
That is
That is a good movie.
I've never
That's a
watched
good
it before.
movie.
Mrs. Doubtfire is a fine movie.
It's hilarious.
It is funny. It is Robin Williams at the peak of his comedy. I don't really like it though. Anyway, any other questions about this lesson?
It's because you like it.
Yeah, I know. I realized that.
2 nights ago, I watched.
Any other questions about this lesson?
No.
Surprisingly so, I actually got the synthetic stuff.
Oh yes.
That's unusual.
I could not.
No, I just watched a lot of Constitution, rewatched the video.
Oh yes. 26. I could not remember how to do the synthetic substitution, and I.
26, he says.
Did you realize?
Okay. Do that with synthetic division.
Oh, no. It's because I just didn't divide the whole thing by 4 when I.
I had that issue too.
Yeah, you got to divide not just the divisor, but also the dividend, and I don't remember which one's which, but you have to divide them both by that leading thing.
Oh wait, I didn't divide it.
All right. Let's look at the next lesson, the ones we did. We just did a few because we're not done with that lesson.
2 through 8.
Yeah, that sounds correct.
It took like 3 years.
You got the tedious ones out of the way this time, and then we're going to do other stuff that's less tedious next. So number 2, you ready? Because I'm not going to slow down and I'm not going to repeat.
Okay.
So get your following finger out.
Could you repeat that?
No. 2 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 6 plus or minus 1/2 plus or minus 3/2 plus or minus 1/4 plus or minus 3/4 or 6. Oh, and yeah, 6, 1/2, and negative 1/2 are the ones. 4 plus or minus 1 plus or minus 2 plus or minus 4 plus or minus 5 plus or minus 10 plus or minus 20 plus or minus 1/2 plus or minus 5/2 plus or minus 1/4 plus or minus 5/4 and 2, the multiplicity of 2, 5 and negative 1/4. 6 plus or minus 1 plus or minus 2 plus or minus 4 plus or minus 6 plus or minus 16 plus or minus 32 plus or minus 64 plus or minus 1/2 plus or minus 1/3 plus or minus 2/3 plus or minus 4/3 plus or minus 8/3 plus or minus 16/3 plus or minus 32/3 plus or minus 64/3 plus or minus 1/6 plus or minus 1/9 plus or minus 2/9 plus or minus 4/9 plus or minus 8/9 plus or minus 16/9 plus or minus 32/9 plus or minus 64/9 plus or minus 1/18, and it is negative 4/3 and 2/3. And finally, 8 plus or minus 1 plus or minus 3 plus or minus 5 plus or minus 9 plus or minus 15 plus or minus 45 plus or minus 1/2 plus or minus 3/2 plus or minus 5/2 plus or minus 9/2 plus or minus 15/2 plus or minus 45/2 plus or minus 1/4 plus or minus 3/4 plus or minus 5/4 plus or minus 9/4 plus or minus 15/4 plus or minus 45/4 plus or minus 1/8 plus or minus 3/8 plus or minus 5/8 plus or minus 9/8 plus or minus 15/8 plus or minus 45/8 as 1/4 and negative 5/2. Do you have any questions on those before we finish this lesson?
Let's do 8.
Let's do 8. The whole list or just the getting the answers? Okay. Okay. Great.
List is the teaching myself. Where we get the factors is from the number in front of the highest and the number in front of without.
Yes. Yeah, and it's this one over this one. Right? Yeah, the leading coefficient and the constant. Yeah. So and it's the factors of the leading coefficient, excuse me, the factors of the constant over the factors of the leading coefficient. Yeah. Yeah. So 8. Okay. So at this point in this lesson, which is it's funny, we accidentally just or not more like coincidentally, we stopped this lesson kind of right at the place where it would stop in Algebra 2. Because in Algebra 2, we do this lesson, and you have to do a whole thing of this. And then we learn some ways to narrow down the possibilities even further, which we're going to talk about today. So we'll just kind of hit this. So what you would do, of course, to figure out whether any of that long old list are factors is you'd have to start dividing them synthetically, right? That's what you do. And the list is big, and we know from the answer key that the answers are going to be fractions, and so you're going to have to guess one of the fractions and YOLO and do the best you can do and whatever else. So you just be shoving stuff in. You'd be dividing for half an hour or longer to find this thing. We can narrow the things down, but we know that the answers are 1/4 and whatever, so let's go ahead and do it with 1/4 and see and just test the book's theory, right? 8, 18, negative 5, negative 72, negative 162, 45.
Wait, no, because it's not.
You could chunk the 8 down below the thingy.
I was
We're gonna-
thinking of synthetic division.
Yeah, you're thinking, well, and you would have, so like the factor would be like 4x plus minus 1. Like once you actually factor the thing out. And so that would be, yeah, but anyway. Anyways, put the 8 down here. 2, 20, 5, 0. Yay, we like that. And then 0,
18. Or
negative 18, negative 90, 180.
I said 190.
Yeah. When I actually stop and look at it myself, great. And if we're lucky, that's going to be 45, negative 45. Negative 45. It did work. Look, we tried all those things and we found one. Right? And so you would do that again, but you could use the depreciated one, right? So you would chuck it and you would try some more. And oh look, we randomly guessed negative 5 halves.
What a crazy guess.
Right?
We're so good.
Out of our list of possibilities.
Oh, you can just put the line where that is, then you can just keep going and just like a giant tower.
Right? Well, we can use the depreciated one once we found them, right? We don't have to go back to this one once we find some. So then we bring 8 down and we do the thing and we get the stuff. Yeah. And then
You can graph that to like find a shortcut to get to like the general vicinity of the answer.
I like shortcuts.
so yeah, you could. Yeah, you could shove that in your graphing calculator and you could look at where the zeros are and narrow the thing. So that is another strategy that we didn't learn in Algebra 2. But there are some other algebraic strategies. And when you do this on a test, I will want you to do the algebraic things, and then you can even narrow it even further using. In fact, I'll guarantee you your calculator has a button that says zeros, and then it'll give you the answer. Whatever, I'll guarantee you that's on there somewhere. But you need to be able to show the algebra bits for that part as well. So you can find the answer and then do the work to get the answer and then whatever. I mean that is the part of the show that we're in right now. That is what we're doing.
Are we gonna do notes next?
I spent like an
Yes.
doing the test corrections for Unit 1.
Nice.
And I just found Desmos, and it was like magical. Just I just
Nice.
put all the stuff in there, and then it just like.
Well, you know your
spits out.
calculator will do that too.
Yeah, but Desmos was easier to use.
Okay.
And
That's
also
fine.
it looked prettier. I just like put my.
The
cursor-
screen is definitely bigger for sure.
I have a big monitor, so it's just like.
Assuming your computer is bigger than this.
I have a big
Okay,
monitor.
let's continue this lesson.
Sure.
Let's learn some tricks to narrow down that giant list. Yeah, we're still in U4. Okay. We're going to look at Descartes' rule of signs, and we're going to do it with it. We're going to learn it with an example. If you want to see the formal definition written out, it's on page 123. But it's a lot easier to just show you how to do it with an example. So Descartes' rule of signs, what it does, the point of it, what it's useful for, is it tells us what kind of real zeros or what kind of zeros we're expecting. Whether we're expecting what we can have certain numbers of positive real zeros, negative real zeros, and certain numbers of imaginary zeros. Okay, so let's do it. We'll do a couple of examples of how to do it. We did this in Algebra 2. I don't know whether you'll remember it or not. That's a different question. So we're going to take h of x equals 6x to the 5th, 8x squared, or plus 8x squared, sorry, minus 10x, minus 15. Okay, so what the instructions on the problem would be describe the number and type of zeros. And what you have to do that is you have to count the changes. So for positive real numbers, we just look at this and we're counting the number of times the sign changes. So it doesn't change from here to here, right? Positive to positive, it changes here. So there's one change, and then that's it. There's only one, which is great. We like ones. Ones are really handy.
Always like ones in math.
Because it could be one or it could be different. It could be one, and to get the rest of the numbers under the positive real zeros, you subtract 2 from this. If we do 1 minus 2, we're in the negative. We can't have negative zeros. So 1, which means in a minute, there's going to be one positive real one, which is great. Because if it was 3, if there were 3 changes, then there could be 3 or there could be 1. If there were 4, then there could be a 4 or there could be 2 or there could be 0. I really like it when there's odd numbers. Because when there's odd numbers, then we know that there's at least one for sure, no matter what else. Okay? So, there's going to be a positive real zero for that one. What about negative real zeros? Well, we do the same thing, but we do it for h of negative x. And what's going to happen on that is it's going to take anything that has an odd exponent and it's going to flip the sign. Because the even exponent is going to stay the same, right? Because when you raise something to an even power, it's always positive, right? So all of the negative exponent things are going to flip. So this is going to be negative 6x to the 5th plus 8x squared plus 10x, right? Does that make sense?
Which signs? Oh, odd signs.
Right. Only ones with odd exponents, because when we shove a negative in there, that negative is going to get spit out on an odd one. Yeah. Okay. So now we count the changes there. So there is 1, 2 changes. So for negative real numbers, there could be 2 or 0.
So you subtract it by 2 all the way down to
Yes,
till
yes.
as well as it goes.
Yes, until 0 or...
Subtract it by 2 once.
Yeah, no, yes, it's, yeah. So if there are 4, there could be 4 or 2 or 0. Or,
If
yes.
there's 6, there'd be 6.
Yes, that is right. Okay, so now there's one other possible type of zeros. There's imaginary. In order to get the imaginary ones, we need to do a little math. So how many zeros does this have?
How many zeros?
Yes.
5.
It has 5. And now, so what we've said previously, and so I want to make sure we're not getting confused, we have said that there are 5 or less. That's not true. There are 5 zeros, period. There are definitely 5. There just aren't necessarily 5 real ones, right? So if it's a graph that doesn't cross but has a turning point up here or something, then there's a 0. It's just an imaginary one. It's just up here.
Why can't we just have imaginary ones?
Okay. So we need to figure out how many possibles for the imaginary ones. Okay. So, how many total are there? There are 5. So, what we do is we just build a little chart. Positive real ones, negative real ones, imaginary ones.
Count all the ones we have.
So, if there is 1 positive one and 2 negative ones, then there's 2 imaginary ones. Imaginary ones always come in pairs, by the way. They always come in pairs because they're always plus or minus. So if you come up with an odd number, then you did something wrong. And probably what you did was they probably all have an x. And so you didn't factor an x out first and do it with that one.
Is that partially why you subtract 2 from each possible,
No. The proof for why this theorem is true is beyond the scope of this class.
Is it calculus plus?
Yeah. If there's 1 positive one and 0 negative ones, then how many imaginary ones are there? 4 imaginary
That means
ones.
we don't have to find but 1.
Right? So then if you were asked to find what they are, you would list all the possible ones and you'd be off to the races.
Yay.
Right? Let's do another example.
Yay.
We'll do this one like as a guided practice. So I'm going to write it up there and then let y'all figure it out, and then I'll catch you up.
What about mustard?
I've never understood, why do English people say, I will catch you up? Like instead of walking, I will catch you up. No, you're going to catch up to them. Why does it that order? If somebody on the internet can explain it to me, I'd love that.
No one's gonna.
Because somebody said it wrong and it just sounded better.
It does not sound better. It sounds way worse. Actually, they're English people. Who knows?
11. Even from the British, probably. To the 4th.
Exactly.
Squared minus x plus 18.
They're weird.
Okay, ready, go.
So we're solving this?
Your same thing. Describe the number and type, whatever I'm trying to say. Describe the possible real zeros of each function. Well, the possible. Oh, we combined two things. It's Descartes' rule of signs and the fundamental theorem of algebra. That's fine. Because the fundamental theory of algebra, theorem of algebra is where we get the fact that there are the possible numbers.
Wait, do you have to have imaginary zeros?
No.
Okay, good.
It just has to come in pairs of 2. Okay, it seems like that. Wait, is
Oh,
there?
wait. Whoops.
Oh, no. There's 3.
How did I get to the top?
Because I also forgot to do this.
This isn't adding up.
3 and
No, it is.
0. 1 and 1. 2. That's what it looks like to me.
No way, that's what I got. Holy crap. I'm so good. Wait, how come?
I got that first.
How come what?
Why do you have 2 lines?
Because there could be 3 or 1 positive one.
That's why everything was messing up.
Yeah.
I was okay, not sure then.
Yeah, I just like didn't put that there.
Okay.
Okay, that makes
All right.
more sense.
That's how that
I
works.
just kind of forgot to put that little 1 there.
I put the 1 there and I'm like, wait, there are 2 separate ones?
We're going to do something so much fun.
I don't like that.
I don't like that.
I don't like that. What you think is fun usually does not equate to.
You know, I had a similar statement made in Algebra 2 earlier,
What was
The
it?
girl said, I said, oh, I love this problem. It's probably my favorite problem on this lesson. She said, well, usually the things you love, I hate. So there you go. We are going to write a polynomial function of least degree. We are doing, so I don't have to write all this down, we're doing page 124, guided practice, 6A. Okay. So we're going to write a polynomial function of least degree with real coefficients in standard form with the given zeros. The given zeros are -3, 1, with a multiplicity of 2. I will show you in a minute.
It has a multiplicity of 2.
And 4i. Okay. All right. So those are the zeros. Now we've got to make the polynomial. Here we go.
That's when you move classes. Four eyes.
Oh, that means there's two of them.
Okay. So that's where we start. What did we do?
It looks as if we just kind of chunked everything and rinsed.
X equals
We did.
this, and then pulled it.
So this would be the factored form of the polynomial. We're going to have to unfactor it because it wants it in standard form, right? So this is the factored version, right? So these are the factors. So all we did was take this, write the sign backwards, this, write the sign backwards. And again, because it's got a multiplicity of 2, right? And then this one, imaginary numbers come in pairs, plus or minus. We have this plus that and this minus that.
Okay.
Now here we go. Let's start doing a whole bunch of junk.
I don't want to start factor it. You always have to factor this stuff.
You want to get rid of the i's first? Is that what you want to do? Sure, why not?
Hey, why do you
So since this is pre-cal, in Algebra 2 we would belabor the point and we would at least once. But what are these to each other? We have a name for that. It sounds like the word for when you go have a relational visit with your husband at jail, but not conjugal, but conjugate.
Okay. I have never heard that before.
You've never heard the word conjugal before? You must not watch crime dramas.
I don't. I think you're the only one. I really don't. So
Okay, there you go. I don't really. Okay, so that was not useful. That's okay. Conjugate is the word. They are conjugates. So since we are foiling, we are distributing conjugates. What's going to happen?
We're gonna do smiley faces.
So yeah, we're going to do the thing, but something is going to drop out because they're conjugate.
The middle number.
Yeah, so we just have to do full, right? Because this is conjugate. Because the O and the I are going to cancel, which is great.
So what is it? Less shiny foil. So it's just.
Don't get distracted by the wrong thing. Pay attention to the right thing so you'll be able to remember it. We don't have to do the outside and inside of this. We just have to do the first and the last, right? We just have to do the first and we have to do the last.
X squared.
Yeah, wow.
Wow.
Wowie.
16.
X squared minus 16. What did I do?
I squared.
I squared became -1. and
Yeah.
you applied an
Oh,
negative
excuse.
one.
I made a mistake is what I did. It should be plus 16. You're right. I did make a mistake. Just so we're clear, 4 times 4 is 16, or 4 times -4 is negative 16. I squared is -1, so blammo. If you are prone to making mistakes like I just did, you should probably do that in 2 steps.
Oh. I would never
At least jot it down somewhere in the margin or something, at the very least, because then you'll be like, do something, because that's an easy way to, because you're thinking, oh, it's negative, but then you forget that it was also negative first. So like, just jot it down for having, like, at least do that much, yeah? Okay, so coming over here, we got all the things. This one and this one and this one and this one. So x squared
Negative.
plus 2x minus 3. I skipped some steps. What did I do?
He multiplied and added together.
I did multiply and add
We
together.
always skip steps up.
3x minus 1x is 2x.
Yep, that's what I did. That's exactly right.
I just like doing like foil.
That's great. You do it, write it all out. It's totally fine. Paper's cheap. I'm going to do this one next so that I don't have to do a triple twice.
Yeah, that would be.
So I'm going to do this one next. Bam, and then bam, and then bam, and then bam. I would also encourage you to continue to do like your alternate colors and that kind of stuff, because then it's easier to not accidentally forget one. Like it takes half a second. So you don't have to do that, but I would definitely recommend it because
Did you say continue?
okay, maybe start doing it for once. There is a reason that I tell you to do the things, right? So x times x squared is x cubed. Those aren't even going to combine. That's cute.
16x.
I'm going to write it in descending order because that feels happy. Minus x squared plus 16x minus 16. Yeah, it's cute.
It's a polynomial. It's not just.
Well, they're all polynomials.
It's not just a trinomial.
Yeah.
It's a quadrinomial.
Yeah, it is.
It's not a word.
Make
It goes. That doesn't apply.
Okay. When it's more than just foil, I not only do I do the loop-de-loops, but I do them one at a time. It's kind of like checking off, making sure you don't miss something. That's what I do, because it's easy to forget what the heck I'm doing. So x squared times x cubed, x to the fifth.
x to the fourth.
X, no, that's a lie.
Negative x to the fourth.
Negative x to the fourth. I don't like you. You're so mean.
16x cubed.
16x cubed.
Pause.
The next one's negative 16x squared, though.
It's true, it is. Negative 16x squared.
These very pretty expressions. What's actually like?
You put so much effort.
Yeah, I don't know how many times you've said for once this year.
A lot.
Because this year he's actually trying.
Kind of. Because
No, you are.
I don't try at least a little bit, I'll fail.
2x times x cubed plus 2x to the fourth. 2x times that is negative 2x cubed.
What is wrong?
Everything. Plus 32x squared.
Plus 16.
Minus.
No, wait. No, minus 32x.
32x plus
That's what I
16 minus 32x.
Oh, we're going to get to my terms.
Maybe because we have big numbers.
Negative 3 times x cubed. And then positive 3 times x squared. Negative 48.
Something.
Yeah.
48x positive 48.
We don't have to do any adding on that one, though. What?
Yep, that one's gonna sit by his lonesome. Now we're gonna go find some like terms and shove them together. Okay, so
It's just hit by itself over there.
this one with this one with, that's it. Okay, so negative x to the fourth plus 2x to the fourth is negative.
Shouldn't we start with
I-
x to the fifth?
Yeah, I was gonna write that down. But I was starting by writing and combining the things that are like combinable.
The x to the fourth.
Yeah, plus x to the fourth.
And then we get 16 minus 2. But then we get to add. No, we get to subtract another 3.
So 11.
We get 11x.
Yep. Plus 11x cubed. plus 19 x squared. And then we probably have a couple of those, yeah. I was looking at the positive 32. I was confused what you were saying, but yeah, that sounds right. Positive 80x.
Isn't it negative 84? No.
Yeah, negative 80, you're right.
C.
X plus 48.
Wait, isn't it negative 84? Hold on. Wait, what number is it?
The whole point of that problem was to take it from that pretty thing up there and make it look that
I
bad.
wrote 30, I added 36.
That just annoys me. You pretty good calculating that one.
Yes, I did. We had pretty little
Come on, man.
zeros.
Using your phone calculator.
Okay, so what I would like us to do next is us to do a guided practice, and I would like y'all to start working on 6B. Ready, go.
Oh, no.
And then here in a moment, I will catch you up.
I don't want to.
Wait, which number again?
6B. You're going to like 6B. 6B is more fun than it looks.
I don't believe that.
Okay.
It looks terrifying.
6B is kind of fun.
Man over zeros is 1 plus I.
Oh, I do need to instruct one thing before you hit that, because you're going to mess that one up. For the 1 plus I one, for the 1 plus I one, it is x plus 1 plus I and x minus 1 plus I. So point is it's minus the whole thing. So you got to distribute, do all that mess, yeah? So, yeah, ready to go.
Wait, no, wait, hold on. Wait, hold on. Wait, no, wait, hold on. Wait, no, wait. It's not as hard as I thought it was.
What is the degree of this polynomial going to be? 4. That's right.
I can count. Yes.
I cannot write an X. First I write a plus and then I write an A.
X
You got this, Landon. You can do it.
squared
I have faith in you.
minus 4 times 2. Oh my goodness, this one is easy.
Well, I don't know if it's easy, but it is easier than it looks.
Easier than it. There's a bunch of stuff that's gonna cancel out.
Yeah, there is.
Is there?
Yes.
Wait, is that just going to kill it?
Kill itself.
That's what I was going to say. And I was like, we're going to get canceled for that.
Oh, I can barely hear y'all, so you know, whatever.
All right.
I mean, I could pull out the other mic and y'all could, and then we could see what happens.
Wait, what?
You two might think we're saying other things and can't believe by saying it's
Could
gonna
happen.
kill itself.
Right? Right? That could almost be funny.
That goes there. What is this number?
Plus
Oh.
I
Minus.
-1. Ooh, yay. That died.
So proud of math class. Ooh, yay. I know it's going to kill itself. Oh, that's going to. Oh.
He's gonna die.
Okay, this is actually not that hard.
Wait, but we're not gonna have any of the other.
Wait, would that just cancel out?
Yeah,
Yeah.
I multiplied that out though.
Wait, is that just?
Yeah, it's not done.
That's just x
Okay.
squared.
What?
X times X is X squared. Yes, I don't know what you're talking about. What are you talking about?
I don't know. That's actually.
Don't try to skip steps.
No, everything just like died all at once. So
Oh, I see.
wait, that is not what happened.
That is what happened with me. How did that not happen with you?
I don't know.
On the first part or the second part?
First part. I haven't even started the second part yet.
So they're conjugates because you really only need to do the first and last. But X times X is X squared. Yeah.
X squared.
Great. And then negative 2x times the square root of 3 plus 2x times the square root of 3 minus 4 times 3, because 2 times 2 is 4. Square root of 3 times square root of 3 is 3.
Oh, okay. I just like killed all of that instead of that last. It was just that last part. Okay, that makes a lot more sense.
Good.
This isn't working.
This isn't working? What does that
My
even mean?
current answer is x to the 4th minus 12x squared minus 2ix squared plus 24i.
Yeah, it definitely did something wrong. Because the i's are going to go away if you do it right.
I must check x squared.
Wait, what did you get?
What's wrong?
Because
X
I got.
to the 4th minus 12x squared minus 2ix squared.
Oh wait, do I have to distribute that
And
negative?
it was like plus 2i. No, 24i. Minus
Yeah, more than
24i.
one, two. I'm not going to.
1x plus ix. Wait, ix is.
I'm not doing that in my head. I don't know why. My brain is not working right.
Oh, that makes sense. That's what I ended up
I-
doing.
I can do that in my head, but for some reason the I is tripping me out. Because you can use the x squared minus 2ab plus b squared. But for some reason my brain is tripping out.
This isn't working.
One.
Minus 2i.
Plus I
I
squared.
feel like it's not going to cancel out, but maybe I should just try and do the math.
This is working pretty well so far.
That's what I'm getting, and I keep ending up with 2i. And the I won't go away.
Just do the math.
Plus 2i.
I did.
You don't distribute the squared.
Would that not?
You don't distribute the squared. It's this. You're squaring a binomial. It's that.
Well, that's what I did, and then whenever I started
No, I was talking to him, not you. I know where you're at.
on the board,
Right.
I was there, and I did that, and I got the x to the 4th minus 12x squared minus 2ix
Yeah.
squared.
Yeah.
So what did I do wrong?
I don't know yet.
Because I followed all your steps exactly.
Oh, I know what's wrong. I know what's wrong. It's my fault. This is wrong.
What is wrong?
And of course it's wrong. I'm stupid and I'm not thinking right. My brain is remembering things that are ugly. This is right, which of course this is right. I don't know why I'm stupid. I don't know why I'm stupid. Okay. This is how you do it. No, because always when we go from you flip the sign, so that's where this minus comes from, and then you have the conjugate for the two versions of I. Yeah, which is why this is going to go, this is going to turn into, I'm stupid. It's fine. It's fine.
We do get to keep the x squared at minus 12, though.
Yeah, that's not changing. That's not going to change.
Except our math needs to change. 4x squared.
That makes a lot more sense. I can see how that will cancel out.
Yay. That worked. All of that just disappeared then.
out of order? What did I do? No, you're not. I am multiplying it all out. That's what I'm doing.
Because I just squared it and then it was 2.
But it's not the same anymore.
I didn't square it, I multiplied it.
You have to
I
do.
do that though because it's inside parentheses,
Yeah.
inside
Yeah,
parentheses.
you have to do it all. So you can do. You could do. You could do what you were doing. It just doesn't. You have to do the outside and the inside, because it's not. These are not conjugates anymore.
Well, I did 1 times 1, 1 times negative I times 1, I times
Oh yeah. You would have to distribute. If you did all that, you'd have to distribute the negative first.
distribute the x first. I forgot
The
to
negative
put
first, but yeah.
parentheses
Yeah,
inside
yeah,
parentheses.
yeah. Yeah, yeah, yeah.
Well, if I distributed the negative first, wouldn't it still come out? No, it would be -2
Yeah.
instead of positive.
There's too many eyes.
X times x is x squared. X times negative 1 is negative x. X times that is xi. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Oh, I did go some weird order over here. What did I do? 1, 2, 3. 1, 2, 3. Negative I. Thank you. Negative xi. Positive I. Negative I squared.
Oh, the eyes are canceling.
Yeah, they should.
Is that-
Yeah,
is that-
that's all the things. Is there a confusion?
My paper got very messy.
Okay, so unmessy it.
At the same time.
Unmessy it. Look up here and make sure you understand what happened. And then you can unmess it yours so you have the notes, right? You have to distribute the negatives first, right? They're not conjugates anymore, so you got to do everything. And then so this is just distribute the negatives, right? And then you just do your big old distributive property, right?
That does make
X
sense.
times X times negative, all the
I don't
things.
know what happened, but something happened in this mess.
What
right
I
here
did was
that
I
is not
distributed
good.
the 2 by 2, I did the parentheses.
Right, and you can do it that way, and then you just have to just do some more distribute. Yes, yes.
It
You-
made it feel simpler.
That's fine. And yeah, how either one of those orders would work fine. We've got some stuff. That cancels with that, and that one cancels with that one. And
Wait, shouldn't that count? No, that doesn't go positive.
so then we've got x squared minus 2x, and then plus 2. Yeah. And then one more distribution, and Bob's your uncle.
My uncle's taller than Aaron.
Okay.
Talking about.
X to the 4th minus 2x cubed plus 2x. So I'll throw this out there. In doing that problem, I made multiple mistakes. I mean, of course, doing it on the board is different than doing it at home on the paper. But problems like this are not hard, and they're extremely easy to make little mistakes on. So use the strategies that I'm giving you, and you will you will make less of those.
Shouldn't that be 2x squared?
Which one?
The very last one. Plus 2x, shouldn't that be 2x squared?
Yeah. Oh, x squared plus 24x
Just talking about.
minus 24. Well, and that I even know why I made that mistake. It's because my brain was thinking about telling you what I stopped and told you, and I I even know where that mistake happened, like where it came from. Now this one, I don't know where that came from. I probably was talking. And then we got some like terms. We shove them together. And then we're done. X to the 4th minus 2x cubed minus 10x squared plus 24x minus 24.
No, that's what I got. No way.
Great. Okay.
Now we can go
Okay. Times it. So we're not going to do one from example. That's weird. Why did they put example 7 and then because example 8 is like easier? Oh, because they're irrational. That's why. That makes sense. So we're not going to do those examples, but I'm going to explain to you. Make sure, because it's not anything new. It's just using stuff you already know with these tools to answer the thing. If you're given a function like this and asked to find all the zeros, you just follow the tools to figure out what they are, right? And go back. Active. What? Right. Yeah. So you're going to end up with whole numbers if you end up with anything pretty, which you don't. Like this particular problem would be this wouldn't be one that was asked to do that because there aren't any non-irrational ones. This one, if it was anything, it would be like example 8, where they give you one of the factors, and so you can factor, and so you can do some division and do the things and whatever else. But yeah, so I'm going to assign you the rest of the homework on this set, and then you're going to go home and do it.
Oh, man.
Or do it at the golf course or whatever you do with your life. I don't know.
Why did you not do all the work?
He's on green, just
That'd be
x
hilarious.
squared plus 4x minus.
That's how it feels right now. My
Wait,
score's
wait, I gotta put.
It's my turn.
You right now.
Page 127.
No number, you're
Page 127. Numbers. What? That's crazy. 10 through. Actually,
It might be close.
let's do this a little bit different since today is Tuesday. Let's do 12 through 12 through
Why did I just erase my 10?
I don't really want to do that one. So
We can do some omitted shit if we want to. I like doing some
54
54. What?
every third.
Okay.
Oh. We're only doing one every 3?
Yes.
Okay, that's fine. 12.
So we do 12, 15, 18. Oh wait, we're starting on a multiple of 3, so we can just...
Yeah, that was why I changed it. It's almost like I had an intelligent thought. Okay, goodbye, guys. See you Thursday.
I love how nobody's moving. We're just sitting.
Now
I was circling all the homework problems I gotta do.
So you're one of the people who writes in the book.
Oh, that's true.
B, both years I've gotten the book, there's all these different numbers that are circled. Why? I'm not doing these.
There's a bunch of numbers already pre-circled in my book, and it's always the exact same ones I have to do.
No, look at this. 14 was circled. 20 was circled.
Maybe that person couldn't do every third, they couldn't figure out how
Do
to
we
do
need to
that.
go all the way to 55 or whatever?
Oh wait, here's these.
I forgot to write down this bullet.
Okay, thank you.
I actually made them kind of pretty.
It looks really good.